Hi everyone. Today we'll start a new chapter, the chapter 7, and with the section reasoning in geometry. So in geometry, specifically, we need to know some basics to uh, to learn new things and to also to have a logic reasoning and to solve some geometrical problems. So geometry, means a lot of angles, geometrical shapes like triangle, like parallelogram. It means a lot of things like parallel statements, perpendicular statements, and as I said before, I mentioned before, a lot of triangles and working in these triangles. So first of all, for example, we have the first example here to find x. First of all, what we mean by x here. So x, it is unknown. So normally x refers to an angle. In which triangle? Normally it is an angle in both triangles ADE or ACB. Good. What we have in the first triangle? In the first triangle, we have two unknown angles and one angle. So it is impossible to find the x from reasoning basing on these angles. Good. Why? Because we know in any triangle, the sum of angles equal to 180 degrees. Also, if we if we ask ourselves about x in the bigger triangle ACB, for example, we have a x as unknown, we have a b, we don't know the measure of b also as an angle, and we have a 70 degree as an angle of the angle C. Good. So also it is impossible to reason about or basing on the sum of angles in the biggest triangle ACB to have x, for example, or to calculate x. So we should find another reason or another way to solve and to find x. What we have in particular in this, for example, figure, we have, it is obvious, remarkable that we have two parallel lines. Okay, good. When we have parallel lines, we have a lot of consequences can flow from having parallelism. So we can, for example, find a letter F corresponding angles, letter F. So we have a F here. In this way, we have a F with the arms of F are the parallel lines. So normally this angle equal to this angle, so it equal to 50. Good. If we have a 50 here and a 50 here, so if we reason, if we, for example, we based our work on the angles of the bigger triangle ACB, for example, so we have a 50, we have a 50, 70, we have a 50, and the remaining of 180 is x. Okay, so normally x equal to 180 minus the remaining sum, 70 plus. So normally we can subtract 50 and we subtract 70 in the same time. So to obtain finally x equal to 60 degree. Or we can, for example, we can forget everything here. Okay, and because we are having, okay, these two parallel lines, we search for F, another F. We have another F with the arms of F are the parallel lines. So normally we have a parallel line, so we can complete our F, which is, okay, flipped upside down. Okay, so normally this angle equal to this angle. So normally this one equal to 70 degree. As a result, we can, okay, analyze, or we can work in the smaller triangle ADE. Okay, we have a 70, we have a 50, and we know that the sum of all angles x plus 70 plus 50 equal to 180. So normally we obtain a simple equation, okay, and we can find easily that x equal to 180 plus we move it to the right minus 70 plus we move it to the right minus 50. So we'll obtain also the same value, 60 degree. So normally in geometry, we can find multiple ways to solve the problem, and it is not a unique way. So normally, first of all, the diagram contains triangles and parallel lines, so we look for appropriate properties of these to use. I mentioned here some review, okay, about what we mean by complementary angle. Complementary angle when the sum of the angle are adjacent, subsequent, or we can say consecutive, and their sum equal to 90 degrees. Supplementary consecutive angles with a sum equal to 180 degree. We can say that these angles are supplementary when they give us a straight line. Alternate interior angles when they give us the letter Z, with the arm of Z are the parallel line. So we have a parallel line here, two parallel line, and the arm of Z. This Z is not what we use to this Z is the yes, it is the common Z that we know, and we have the Z in this way. So we have a Z in this way with the parallel lines are as the arms of Z. So we can have the Z and the opposite of Z. So normally we search for Z to find the alternate interior angles. This angle equal to this angle, or this angle equal to this angle. Good. We have also alternate exterior angles. So like as we see here clearly, okay, we have what we say alternate exterior, but I want you to focus on this one, and also this one. Also, if you have parallel lines, okay, and you have another third line cross these two lines, okay, so normally the interior angles, okay, found in the same side of the third line. So that's are supplementary. What we mean by supplementary? So supplementary, if we add it, we obtain 180 degree. Okay, in the same way, we had the same side exterior angles, same side exterior angle. We have two parallel lines, okay, and the third is crossed here, crossing these two lines. So the exterior from the same, this is this one is found as exterior angle, and this one also. So exterior angle, the sum of exterior angle equal to are supplementary, their sum equal to 180 degree. Okay, vertical angles, we can say it as the opposite angle, opposite that share the same vertex. So normally we have a vertex here, we have a vertex here. So opposite to each other are equal, are congruent, opposite to each other are congruent, and opposite to this vertex are congruent, and the same for this one. Corresponding angle, as I said before, the letter F. We have 4 letter F here. This letter F. So this one equal to this one, or we can say this one and this one are equal. So this one equal to this one, or we have this F. So this one equal to this one, or we have this F. So this one equal to this one. So the corresponding angles, these angles are in the same position in different intersections, so are congruent. So let's move to the following exercises and to find out which property to use in each case. For example, we have this one and this figure and this diagram, and they complete the following to find the values of polynomials in the following diagrams. and with giving reasons. Good. First of all, we search for something we can base on. So, for example, we have for example, vertex here. Okay, we have a vertex, and there's clearly seen in this diagram that we have this one and this one are opposite vertical angles. Okay, opposite vertical angles, because this is a straight line and this one is a straight line, so normally opposite. So normally 2z equal to 46 degrees, equal to 46. So normally z, if we want to solve this simple equation, 46 over 2, we divide both side by 2, or we can simply say that we move this numerical part multiplied here, so we divide it in the other side of the equal to obtain 23 degree. So z equal to 23 degree, so 2z equal to 46. So we have a 46 here. Okay. Moving to find, for example, another thing. For example, we have a 5y equal to 55. Why? Because also we have a opposite vertical angles here. Okay. So in the same way, we find a y equal to 11 degree. So 5y equal to 55. Good. When we want to complete to find the other polynomial x, we find that FPE is a straight line. So all these angles, the sum of all these angles equal to 180 degrees supplementary angles. So we can say that 5y plus x plus 46 equal to 180. Finally, x equal to 79 degree after solving the equation. Okay. Same for example here, they gave us BF bisect the angle EBC bisects. So normally it is like we say that BF is bisector. So normally it divide the given angle in the half. So normally if we have a y here, so we have a y here. Okay, good. Normally we have 90 degree here, because we have this mark, and this mark refers to the 90 degree, okay, perpendicular statement. So we have a y plus 90 plus 70 give us a straight line, so supplementary angles, so 180 degree. So the sum equal to 180. So after some simplification, we'll obtain 2y equal to 20 degree, and finally y equal to 10. Okay, so a line bisects an angle means it cuts it in the half. Okay, and we can complete these diagrams in the same way. We don't have to. We can tackle the problem from starting from any information, any property we have, but should take attention and take care about the property that we start with. Okay, we don't want to face a problem with two unknowns in the same equation. For example, if we start by this one, they gave us that SP bisect this one. So normally we have a Z and this one. Okay. Also SQ bisect SQ bisect this angle. So we have this one equal to this and this equal to this. Okay. They asked us to find Z. They want us to find Z. No problem. So we can, for example, put as x here. Okay, x, because these two angles are equal, and we can put y here and y. Okay, and we can complete to find that when we have two angles and we have two angles and we have a side in common, so normally these two triangles are not, we can't say that are congruent, but they are identical to in a ratio, or in a ratio. Okay, we will find this property later, and we'll explain it later. Okay. Normally, they will obtain that they. Let's find, for example, 70 plus 2x. So normally we have a 70 in the biggest triangle, on the triangle RPQ, plus 2x, okay? Plus 2y equal to 180. Normally, because we are facing here a equation with two unknown here, the x and the y. So normally we need another equation that also put us in the same. So let's talk about the angles of the smallest triangle, the triangle PSQ. So what we have normally here, if we arrange our equation, we'll obtain 2x plus 2y equal to 180 to 180 minus 70, so 110 degree. This the first equation. So let's move to work in the triangle PSQ. We have a x, 1x, because we have a 1 mark of this. We have a z. We have a y. All these angles equal to 180 because we are working in a triangle. Okay. So let's move to talk about x plus y. Normally x plus y equal to 180 minus z. Good. And we have already we have 2x plus 2y equal to 110. Okay. When we seek to find the solution, what is the relation between this the first equation, the second equation? Normally we have here 2x, 2y. Okay. Y is not to, for example, to multiply this equation by 2. If we multiply the whole equation by 2, so we should multiply each term by 2. We'll obtain 2x plus 2y equal to 360 minus 2z. How to combine these two equations to find the z? Normally, we have a 2x plus 2y. We can replace it by 2x plus 2y. We can replace it by its value 110. This is the way to combine the two information that we succeeded to find from the two triangles. So normally we'll obtain that 360 minus 2z equal to 110 degree. So it is one equation with one unknown, easy to solve. So normally we can move minus 2z to obtain 2z equal to 360 minus 110. So normally we'll obtain 250. 250. 2z equal to 250. So z equal to 250 divided by 2. So 125 degree. So z will obtain easily that z equal to 125 degree. Okay. Good. So let's move also. We have a diagram. They give us that EGB equal to CHF. EGB, okay? EGB, this one, the x equal to CHF. Good. Because we have, for example, opposite vertical angles. So normally this one equal to x, and as vertical angles, we have this one equal to x. So because we find like the letter Z with two angles, so we have we have a corresponding angle, or we can say also we have a corresponding, or we have alternate angles, interior and alternate angles. So then we can say easily that AB parallel or to CD. You can prove that AB parallel to CD in different way. You can say also that we have a x, okay? So we can find the letter F here. When we find the letter F, we can easily figure out that we have the letter F here, so it is a corresponding angle. Then AB and CD are parallel. So we can use any property that we already gave this its review, okay, to find out if we are talking about parallelism or another thing, okay. You can move to also analyze by yourself these exercises, and this one are also easy. For example, we have a 2x plus 2y equal to 180 degree. Okay, and also we can find that this angle, if we divide it by 2, equal x. And this angle, if we divide it by 2, equal to y. And we have no, if y 180 divided by 2 equal to 90, so normally x plus y equal to 90. So this angle equal to 90. So normally we can also memorize the fact that if we have two angles, supplementary angles, if the line that bisect the first and the line that bisect the other angles, they will compose a 90-degree angle, or they are perpendicular. They will become perpendicular to each other. Okay, these are the most important idea of this section. Thank you for listening. Bye-bye.